Alright, example 3, maximization problem. Case example 3.1, we are using both marks x1 and x2 to produce daily given limited amounts of labor and clay. So this is our linear programming formulation. Okay, so in graphical solution, first we need to convert all the inequality into equation. So first constraint, x1 plus 2x2 less than or equal to 40. Change the inequality into equality, like this, yeah. Okay, so by looking at this equation, you need to find one line, yeah, one line. So I just change, if my x1 equal to 0, my x2 will be 40, you divide by 2, it will be 20. Okay, and when x2 0, x1 will become 40. Just simple equation lah. So I have here one line, that is x1 0. Okay, this will become one line lah, from point 0 20, and also I have 40 0. Later we will join this two dot to become one line. Here also I have one line. Okay, second inequality, it will become equation. So just substitute 0 here, it will become 0 40. Simple equation, yeah. So here I get 0 40 and also 30 0. Okay, so this will become one line, and here two line, 1 and 2. Okay, why I substitute 0 into this equation? To get one line. Okay, first I need one dot. If I have two dot here, it will become one line lah. Dapat satu garis. Okay, so ada dua garisan di situ. So by using your graph paper, you need to shade the feasible solution area, yeah? Second step. So I have my x2 axis, yeah? In your graph paper, you have one x2, one axis for x1. So where is my line of 0 20 and also 40 0? 0 20 here, okay, and also 40 0 here. Okay, so join these two dot, it will become one line. So here kan, I buat panjang sikit, dia akan jadi, ya. Yeah. Okay, ni let's say lah, ini dia punya axis. Okay, so kalau ini I drag kan, tak perlu drag lah, cuma I nak labelkan di sini. Ini adalah kita punya apa tadi, x1 plus 2x2 equal to 40. x1 plus 2x2 equal to 40. Okay, this is the line. Second line is for second constraint or second equation here. 4x1 plus 3x2 equal to 120. 4x1 here 4x1 plus 3x2 equal to 120. Okay, next, our non-negativity constraint, 0, x1 more than or equal to 0 and x2 more than or equal to 0. So how to shade? Okay, how to shade the area? You need to substitute one point. Let's say lah, I use this equation here. So sama ada you want to shade upward or downwards this line, ya, sama ada you nak lorikkan ke atas ataupun ke bawah. Okay, let's say lah, kalau I ambil 30 here, you masukkan dalam this line. Okay, ni kalau lah I ambil 30 and 0, okay, so I masuk dalam x1 plus 2x2 less than, dia punya inequality, less than or equal to 40. Betul tak? Okay, so 30 plus 2 plus 0, so sini akan dapat 30 less than or equal to 40. Betul kan? So this is true, so we have to shade downward lah here. Sebab apa? Dot tadi di sini. Kalau lah let's say you ambil somewhere here 50 lah for example, okay, 50 0, 50 kalau you substitute dalam kita punya inequality, true or false? Sini, okay, so 50 kita dapat sini less than or equal to 40 ataupun tidak. So sini false. Sebab itulah lorikan tidak ke arah atas. Okay, so ini salah. So kita lorikkan di sini. Sama juga dengan ini. Second line, you have to substitute lah. Let's say lah kalau you ganti masuk 0 0, 0 less than or equal to 120 ataupun tidak. Kalau true, so we shade here. Okay, so here all the region here we shade, but we have the non-negativity constraint, that is x1 more than or equal to 0, x2 more than or equal to 0. Okay, again, if you're confused, I highlight back. Okay, first line tadi we have agree, blue color here. So semua lorikan ni kita lorik. Okay, so next, if I use green color here lah, semua kita lorik. Okay, so next kita ada non-negativity di sini, ya, di sini dan di sini lah. Okay, so basically the shaded area ataupun the visible solution area ni, the one that having all the shaded from all the constraint lah. Kalau tengok kat sini, mana yang bertindih, area ini yang bertindih. Okay, so area ini yang satisfies all the constraint. Right, so third step barulah kita gunakan solution in order to get the point that produce the optimal solution. Okay, so let's say I use the first method, that is isopropyl solution method. Okay, just now kita baru sketch dan shaded the area. Okay, but which point give the optimal solution? Okay, which point give the maximum profit? That's come the optimal solution lah. So here we use in order to get the isopropyl line, you have to refer your maximize of profit Z tu tadi. Okay, we have equation of Z equal to 40x1 plus 50x2. So let's say I use 800 can be any value lah, tapi since 800 ni you can get this dot to become one line. Dia nampak cantik kan bila kita plot. Then I use 800 lah. Maybe you can use other value like 1000 or 0 tak boleh lah, kalau let's say sini 0, semua akan jadi 0. So you have to think one value that can very nice plotted here. Okay, So let's say 800 here. So if you change this, you can get point of 0 and 16, 20 and 0. So where is the line? Here, somewhere here lah. Somewhere here, 20 and also 16. Okay. Let's say here is the line. Kalau you guna graph paper lagi lebih jelas lah. Kalau let's say you are using your graph paper. Okay. Let's say this is the line of 0, 20, 0 and also 0, 16. Okay, so in isoprofit solution method, we need to move away from your origin. Move away. So kita akan gerakkan dia ke atas lah. Sampai mana? Sampai habis shaded area region. Okay, dia akan sentuh pada point yang ini. So you use your ruler, move this red line upward sampai habis shaded area. So di sinilah dia punya optimal solution. So optimal solution kita adalah pada point 24 and 8. So how to get this point? Kat sini kan, kalau you tengok, you have two equation, that is mana tadi equation kita? X1. Sekejap. Okay, X1. Okay, I ada X1 plus 2X2 equal to 40, and also I have 4X1 plus 3X2 equal to 120. So how to solve this equation? Whether you use manual or you use calculator. So when you use calculator, just find mode equation EQN, mode. Lepas tu you find EQN. Okay, number 1, unknown. You scrollkan lagi ke tepi. You need to scroll lah. You need to scroll. Just press unknown 2. Press 2. Okay, so A1 kita here. Coefficient for X1. A1 kita adalah 1 equal, B1 kita adalah 2 equal, C1 kita adalah ini 40. Okay, so A2 kita here. Ni settle ya, A1, B1, C1. A1, B1, C1. A2 kita adalah 4, B2 kita adalah 3, C2 kita adalah 120. Then you can get solution for X24, Y8. So maksud dia apa? X1 kita 24, X2 kita adalah 8 lah. Okay, and you substitute this value into the equation of Z, you get the maximum value of profit.